Bayesian regression updates prior beliefs with data to make probabilistic predictions. Welcome back to my channel. Hope you all are doing good. Today we are going to talk about Bayesian regression algorithm and its concepts. And guys, while subscribing, please don't forget to hit the bell icon because you will not miss the latest updates as I am uploading contents on regular basis. So you will stay updated with the contents. You will not miss them on your regular study or regular practice. So let us start with the topic today. Let us start with the topic on how Bayesian regression algorithms works. So first let's understand the concept. So this regression algorithm is based on, as the name says, it's based on the Bayes theorem. And what our Bayes theorem, how our Bayes theorem works, and we already have gone through during our previous videos of probability theory and everything. During that time, what we studied, that Bayes theorem is completely based on the prior belief and the posterior output, right? And the likelihood to convert the prior belief to the posterior output, correct? And this whole Bayes theorem is the probabilistic theorem, complete probabilistic theorem. It is here all the parameters which we are going to consider are going to behave the way on how one variable or the one parameter is going to be affected by the other parameter based on a probability distribution concept. And here, unlike our regular regression, which we are in general or in normal concept which we are talking about as a ordinary least squares. When we are talking about ordinary least squares, it is based on the point estimates. What is point estimates, guys? Point estimates is the one where we are getting one line and each parameter is having intercepts and coefficients. So those are your point estimates, right? Because each parameter is associated with a coefficient to detect or to understand or to know the pattern of the behavior with the dependent variable, right? So those are your point estimations. However, in case of Bayesian regression, it is, like I have already mentioned, it is based on the probabilistic distributions over the parameter values, and it is going to detect whether any uncertainty is present in the predictions or not. So that is your Bayesian regression algorithm. And here I have shown you the concept in formula wise, like how it is getting converted. So like I have already mentioned, how it is behaving is it's like hypothesis. First we are going to define a hypothesis, and based on that hypothesis, how an event is occurring. So P of A is my prior hypothesis or the prior event, and P of B is the evidence, either regularization or a normalization of the parameter. Then likelihood is the the event, how it is behaving on the hypothesis. Then posterior is the output based on the hypothesis which you are going to get. So these are the terms which are associated with the Bayesian regression, and we will understand each in our upcoming slides. And in this image, you will see how it behaves, like how this probability concept or how each parameter is behaving based on the probability concept. You can see that we are all getting this distribution, right? Normal distribution curves and all, right? So this is your Bayesian, like the fundamental concept or the fundamental principle of Bayesian regression algorithm. Let us understand how Bayes theorem is getting converted. So what is a Bayes theorem, guys? Like I've already mentioned, we will be having some data and we will be having some hypothesis to determine the the feasibility of the data, right? Then what we are going to do, we are going to understand the complete behavior of how that observed data is behaving on that hypothesis concept. So this is the formula, the way I have shown it, P of A or B, like that. So here I have taken one simple concept. You can see that P of H or D. H means your hypothesis, where we are talking about the parameter or the model or the assumption. Anything you can take here. And D is the observed data. So for that parameter, how the data is behaving, right? Then P of D of H into P of H divided by P of D. We will understand each term here. So P of H means what, guys? Like we have discussed in our previous image, P of H is a prior. So what is a prior? Prior means you will go ahead with a belief or the knowledge on how the data is going to be behaving with the event, right? So when we will think that, okay, if like our observation is true, or the term which you are calling that as a priori, right, for that, then with this P of H, or with this fundamental, what we are able to understand, we can know, or we can assume that how parameters are collecting data. We can be able to know like what is the source of collecting data with prior. Then it will act as a starting point for the Bayesian learning. Then next thing is what? We have likelihood. These are the three terms you have to understand, guys. Prior, likelihood and posterior. Likelihood is what? Again here, this term, right? Let me get my pen. So here P of D of H is your likelihood. So what exactly it is happening? When I'm talking about likelihood, that means it is getting the probability of observing the data to a given hypothesis. Suppose, take one example. If you have a coin, if you have a fair coin and that fair coin is flipped, and when you're flipping the fair coin or tossing the fair coin, you are getting, like, you will get an assumption that I am going to get head 8 times out of my 10 toss or 10 flips, right? So here, when you're talking about a coin, that is nothing but a hypothesis. That means it's a complete data, right? And when you're talking about D, that is nothing but a number of tosses. So here, this is the way we can represent, because what we understood that when we're talking about the probability concept, binomial distribution or binomial distribution is the one which is coming into your mind, right? So this is your binomial distribution, and this is the formula for that. So we understood that, okay, with this concept, I can go ahead with my binomial distribution, and this should be the parameters for that. So we understood the likelihood from here, that it's going to show me the binomial distribution. Then what is the posterior concept, guys? Posterior is your output. This is your output, P of H to D. That means when we are talking about posterior, we will go ahead with the belief or the updated belief that how hypothesis comes into life after considering the data. So two things, right? Here, hypothesis and the data, the behavior of the data towards the hypothesis. So that is nothing but a probability concept, and your Bayes theorem works on that. And here, when I'm talking about posterior, it's completely based on the prior and likelihood. So these are the three terms you can remember during your Bayes theorem. Then we will see how Bayes theorem or the Bayes regression formula is coming into picture. And you don't have to remember this, you just need to understand the concept when I am explaining this. So during our Bayes theorem, what we are doing, we are formulating our regression using the probability distribution, right? Whether we are not, like here we are not proceeding with the, our normal regression formula, correct? So here my target variable or my response variable will stay same. However, in our regular regression, we are going here to the intercept points, then coefficients like beta 0 plus beta 1 x1, beta 2 x2, like that. Here, we will not go ahead with those single values. We will assume the probability distribution of each points here. And this is the particular formula, or this is the particular consideration when we are going ahead with the Bayesian regression. Here, let us understand what are the terms, like what is the meaning of these terms. So here, y is your target variable, right? This is your target variable. and it follows a normal distribution, right? Where and how a normal distribution curve is coming into picture, guys? It is completely based on your mean and variance, correct? When we are talking about how y is getting generated in case of Bayesian regression, we will go ahead with the mean. How my mean is coming into picture here? My mean here is going to be the transpose of the weight matrix multiplied by the predictor matrix. That means weight matrix is what, guys? Weight matrix is our coefficients matrix. Like we have a coefficient associated with each weight or each variable. So that is nothing but a weight. That means here we will get a matrix like beta 1, beta 2 till beta n, right? So that is nothing but a weight matrix. Then after that we will be having your variable matrix like till xn, right? You will take that, you will multiply that, and after that the variance you have to take, and the variance should be the square of the standard deviation by multiplying with the identity matrix, because here we are completely understanding the multidimensional formulation of the model. So this is how we are going to, or how Bayesian regression formula is getting derived. And you don't have to remember this formula, just understand the concept that they are considering the matrix forms of all. They are not considering a single point estimations here. Here I have shown one, like the same formula here should be considered this one, right? This is the way we are considering the formula. So the same thing I have explained in a different way. So let us understand that. So here, like if we understand in a practical way, this is the formula which we have to consider. So first, what is the target here, guys? Our target is to get the posterior distribution of all the parameters, right? And when I'm talking about posterior distribution, that is nothing but a probability distribution, right? And this is the formula we already discussed. This is your posterior distribution, this is your likelihood, this is your prior, this is your normalization, right? And the same thing with simplified manner, it was mentioned here. You can see likelihood into prior divided by normalization. And through practical way, we will see how we are going to, like what are the factors it is affecting when we are deriving the Bayesian regression formula. This is the thing, guys. You don't have to understand much about it. Just understand what exactly are these, formulas, or how these things are coming into picture, which I have shown in this image. Now we will understand in what are the factors or in what are the sectors these Bayesian regression can come in real, right? Or with an example. Just understand a scenario. Just you are buying every day, all your belongings from a supermarket, right? And if you'll go ahead to any supermarket and if you'll see there during any seasons or during any festive seasons, you will be seeing sales of the supermarket, right, of all the products, either launching new products there. So first we will understand the initial sales before moving here, right? So that is our prior here, correct? We will go ahead with the initial sales, right? The initial numbers on how, like what is the quantity of items present. Then you will see, like we will go ahead and understand how my customers are purchasing that item during that during that phase. Then we will take them and we will forecast the next festive season based on the prior and the data, current data or the customers data, right? So that is how I can get my output. So here you can see that everything is based on my understanding of the pattern between these three events, correct? First, I am understanding my initial sales or the initial count or the initial stock of my item. Then after that, I will understand the customer's behavior on purchasing that item. Then after that I will combine them, right? And whenever we are going ahead with any Bayesian regression, you should be considering the regularization technique here. Why? Because regularization is for what? That is for handling the overfitting concept. But here what is happening, in which cases overfitting comes into picture, guys? When you have less amount of data, correct? That is one more factor. So when we have less amount of data, what exactly is going to happen? The validation data or the test data will be less, and the train data will be also less. So when less data will be there, the model will not understand the correct pattern, and it will not sit in the memory properly of the model. With that, what exactly is going to happen? It may fail to give you the correct output. So in this case, why that is a crucial part? Because here in Bayesian regression, most of the times, not most of the times, always it is preferable to take less amount of data. It is not suitable or preferable for more amount of data, because here the process will be more hectic, right? Because you have to have each probability distribution for each parameters, then you have to understand, combine them together, and all those steps will be there. So for that, it is getting a bit messier in approach. So for that, we can add regularization technique during our Bayesian approach. So when we will tell in this example on how the regularization will be applied to the prior variable, then we can say that we have seasons, then days of the week, then different holidays, trends, and the promotion indicators. So we will consider them, and we will see how my model is getting parameterized for that, and we will see how the forecast is coming with all these factors. So that is how you one particular example which I have told you about Bayesian regression. Then we will see how my algorithm works. How my algorithm works in stepwise. We will understand the concept. So first, what we are going to do, we are going to calculate the prior probability, right? First, that is the first one, prior, then likelihood, then my total probability, right? So just take one case where we have spam filtering system, right? In our spam filtering system, what we have data set of emails where we are going to find the percentage of emails that are considered as spam. And that is our belief, or we will go ahead with that hypothesis understanding. Okay, we have to find out the spam from that lot of data. Then what we will go, so we will give a name as P of spam, or we will say that it's a P of spam. Then after that, what we will do, we are going ahead on finding out the price term, say price term from the spam. So this is how you can represent it, right? P of price to spam. That means here what my model will do, it will examine all my spam mails in its training data itself, and it will find the frequency on which my price appears in them. And it also calculates, okay, the probability of that price appearing in non-spam emails as well. So it will take this and this, both considerations. Then after that, what we have posterior. So where we are going to get the price. That's not posterior, that's the what I can say, normalization, right? We have to normalize that. So here what we are doing, well, after that the model will use the total probability concept to find the chance of having the price word on that. So what we have, this is the final formula. So we are taking the probability of the price term coming in a total spam, then we are multiplying with the spam number of total data set, then we are adding with non-spam with not spam data set, then we are getting the price or the normalization data. Then after that we have finally the Bayes theorem, where we are getting the spam, the price term inside the spam. So this is my updated probability, where I am understanding, if I'll give the further input to my model, it is going to tell me which email is spam, and we will know at the same time that whether that mail is containing price word or not. So that is how my algo works here. Then we have several advantages and disadvantages of Bayesian. So some of them I have already told you. It is better when we are talking about the data set, which is a small one. It's not a good approach for larger one, because here we are not, like here it is not getting trained with the batch learning. It is learning based on the probability density concept, right? And when we're talking about Bayesian algorithm, it is not needed to know the prior knowledge of the data set. You can just go ahead and understand the distribution system, and you can go ahead to predict the output. And there are few disadvantages here as well. So when I'm talking about the model, right, here the process will take some time, like I've already mentioned, because that's why it is not applicable for larger data sets most of the times. And when you have a lot of data, it is going towards your regular OLS method only. Like you have, just consider that you have infinite amount of data set or infinite amount of data. During that time, it will behave the same as your normal regression only. It is not going to behave in the in our probability regression, right? Then we have, like, once we build all our model, then what is the next step? We have to understand how it behaves with other models, right? So for that we have different metrics, and these are our regression metrics only, where we are using for all regression models, right? So that is nothing but a mean absolute error, then a mean square error, then root mean square error, R2 score, right? Then we have one more important metric here, which is negative log likelihood, right? And calibration metrics. We will see that what exactly is the negative log likelihood. This is a core metric for your probabilistic Bayesian models, and we have calibration metrics as well for that. Let us understand the concept behind it. What exactly is negative log likelihood? So this is a loss function, and again, when we are talking about metrics, all are based on your loss function, right? When we are finding the differences between your actual and predicted, mostly, correct? So here again, this is a type of loss function, right? Where we are evaluating on how my probabilistic model fits on the observed data. So with this negative log likelihood, we can understand that. And here my primary goal, right? Primary goal during the model training is to minimize the NLL. The NLL should not be more, it should always come less. And with, like, what we are going to observe or what we are going to understand with this approach, that when the NLL is less, that means the likelihood will be more. Likelihood means the probability of observing the data on the given parameter or the given model's parameters. And it is a optimal measure for quantifying the predictions, right, on probabilistic models. So like I've already mentioned, this is one of the great factor. Then here, in this case, always your posterior probability is proportional to your likelihood and prior probability. That is a common factor for your Bayesian theorem. Then we have calibration metrics. What are calibration metrics? So we have like for validating your Bayesian analysis, we have some techniques, which is nothing but a Bayesian validation metric, where we are quantifying the model output and the data by different probability distribution comparison function. So what we are doing here, what are the steps here or the inputs here? First, we have to have a model, right? And the data comparison values. What are the data comparison values, guys? That is nothing but your mean square error, root mean square error, mean absolute errors. Those are the differences, square differences, correct? Then after that, whatever the output we have, that output we will compare with our data distributions or the density functions, probability density functions. Then once we have them ready, we will create a function, comparison function, and we'll understand the difference. Once we get the difference, we will come to an agreement function which will accept or reject the model based on that capabilities. So that is nothing but a Bayesian validation metric. And with this, we have completed our complete understanding on Bayesian regression and its concepts. So we will understand the real world example which are really important, and like I have already mentioned, I'm not going to leave any concepts away from you. I will complete everything for you. You just need to follow and understand all these concepts for your career. So let's meet during our next video. Thank you. That is all for now. We will cover the real world example of Bayesian algorithm, how it works, in our next video or the upcoming video. Please start subscribing if you have not done that. If you really like the content, if it is helpful or if it is very impactful, just go ahead and do that. Please like, share your comments, share your valuable feedback, share this channel link to all your friends who are in needs to understand these concepts and all. And this is a trend nowadays, AI and ML. So everybody can learn and grow in their career. So let's talk during our next video, and see you till that time. Bye.